Want to secure 10 to 15 extra marks in the PSLE? In the next 15 minutes, you'll be learning 5 must-know ratio techniques that will help you solve almost every ratio problem in the exam. Before we begin, make sure to watch the full 15 minutes of this video so you don't miss out on any important tips. The first technique is constant part. Let's look at the question. There are some boys and girls in the hall in the ratio 4:3. Some boys left the hall and the ratio became 7:9. So let's write down the ratio of boys is to girls. Now, before the boys left the hall, there were 4 units of boys and 3 units of girls in the hall. After that, the ratio became 7:9. According to the question, only the boys left the hall. Number of girls should not change. However, according to your ratio, the number of girls have changed from 3 to 9. So we must make sure that they stay the same. How do we do that? Take the entire ratio, multiply it by 3. Now we will have 9 units of girls and 12 units of boys. Notice that the number of girls remained the same. So actually, when we say constant part, what are we referring to? We are referring to the girls. In this question, the girls is the constant part. Constant meaning unchanged. The number of girls did not change. Now that we have made sure that the number of girls are the same, can you just ignore the old ratio? We'll not be using it. Now, observe the new ratio of boys. 12. From 12, the number of boys dropped to 7. From 12 units to 7 units, it means that we have lost 5 units of boys. Since the question says that there were 35 boys who left the hall, we can then conclude that the 5 units represents 35 boys, 1 unit represents 35 divided by 5, 7 boys, and how many boys were there in the end? There were 7 units of boys left in the end, which is 49. There we go. So that was constant part. One part changed, the other part stayed the same. In this case, the girls were the constant part. Now, our second technique is constant difference. Whenever you see the word age, always suspect that it might be a constant difference question. Why? Now, imagine we have person A and person B. Right now, person A is 11 years old. Person B is 21 years old. What is the difference between their ages? There is a 10-year gap. Okay, assume 5 years later. Person A is going to be 16 years old and person B is going to be 26 years old. Guess what? The difference between their ages has remained the same. So, why does that happen? Well, I'm sure everyone will agree that we all grow older together every year. That's why the difference between our ages will never change. So, applying this concept to this question, we know that the difference in ages between any two people will always be the same. Let's write down the ratio of Jessie and Kenny's ages. 5:3. What is the difference? The difference between 5 and 3 is 2. So this is right now. Now, what happens 8 years ago? 8 years ago, Kenny was half as old as Jessie. So let's say that Jessie has a ratio of 2 units and Kenny is represented by 1 unit. So Kenny was half as old as Jessie. The difference is 1. Now, knowing that the difference in ages between any two people will always remain the same, we have to make these two ratios the same. How are we going to do that? Multiply this by 2. We will get 4, 2, and 2. Now we know that the difference is the same. Please ignore the old ratio. This is old. We're not going to use it, so don't confuse yourself, okay? How many units did Jessie lose? Now, both of them has lost 1 unit of age. So, do you know what this 1 unit represents? How many years does 1 unit represent? Read the question. Read what we have written down. What is the difference between now and 8 years ago? The difference is 8 years. Therefore, a difference of 1 unit is equal to 8 years. So we're going to write down 1 unit represents 8 years. How old was Jessie 10 years ago? Let's find out how old she is right now, shall we? Right now, she is 5 units, which is 40 years old. So therefore, we can say that 10 years ago, Jessie is 30 years old. Now, this next technique is going to be a little bit higher level. everything changed. Let's read the question. Ali and Billy had money in the ratio 2:1. Notice that I'm writing units. And I'm also leaving a lot of empty space here. Why? Because when you continue reading, you notice that Ali saved $60 and Billy spent $150. So it gives me space to write that down, okay? In the end, the ratio became 4:1. Let's use cross multiplication to solve this. What is cross multiplication? Say we have 2 over 7. I'm sure you agree it equals to 4 over 14. Let's cross multiply. 14 times 2 gives us 28. 7 times 4 gives us 28. Notice how the fraction is gone, and we have two whole numbers of equal value on both sides of the equal sign. So let's use this on our ratio. When you cross multiply, you get 1 times this. That will just give you 2 units plus 60. And now we're going to take 4 multiplied by this, which gives us 4 units minus 600. Please make sure you remember to multiply every single number. You can't just multiply your 1 unit. You must also multiply 150. So the next thing I want you to take note of is, if I have 5 plus 3, it'll give me 8. What if I would like to move the number 3 over to the other side? Now, can I write 5 equals to 8 plus 3? That's obviously wrong. How am I going to make it right? Well, just change the plus to a minus, okay? So we notice that when we move a positive number from one side to the other side of an equal sign, it becomes negative. Same goes for negative numbers. 5 minus 3 is 2. So if I bring the negative number over to the other side, can I write 5 equals to 2 minus 3? That's obviously wrong. It will change to positive 3. Okay, so let's do this. I'm going to bring the number 2 units to the other side. That will give me negative 2 units. I'm going to bring negative 600 over to the other side. That will give me positive 600. So now I have 4 units minus 2 units equals to 60 plus 600. 2 units equals to 660. 1 unit is 330. So how much money did Ali have at first? Hey, you know what? Ali had 2 units of money at first. Right? We already found 2 units. We don't even need to find 1 unit. So Ali had $660 at first. Now, technique number 4, total unchanged. It is not that difficult to understand. Imagine you have 2 people, A and B. Now, A has $50, B has 100. What happens if A gives $10 to B? Then A would have $40 and B would have 110. But notice something. The total amount of money between them does not change. That's why we call it total unchanged. Okay? So let's solve the question. Sam and Lynn shared money in the ratio 1:5. When Lynn gave Sam $210, the ratio became 1:2. Now, this is before, this is after. And let's find the total amount of money between them, 6 units and 3 units. Now, as I've mentioned, the total must be the same. So take this and multiply it by 2. We are going to get a new ratio, 2:4:6. Now the total is the same. Please ignore the old ratio. You don't want to get confused by it, okay? Sam has gained 1 unit. Lynn has lost 1 unit. Why? Because Lynn gave Sam $210. Therefore, this 1 unit represents $210. And how much was the sum of money? What is the total sum of money? 6 units, which will be $1,260. That was pretty easy. Now, for the difficult part, if. There are 2 ways to solve if questions. 1, by drawing a model, and 2, by using ratio. For those of you who don't like to draw models, it's okay. Just learn. It might come in handy one day. So, model drawing. If Ali gives 28 marbles to Roy, he will have 3 times as many marbles as Roy. So let's just pretend that Ali has already given 28 marbles to Roy, and now Ali has 3 times as many as Roy. There we go. This is Ali, this is Roy. Ali has 3 times as many as Roy. That is after Ali gives 28 to Roy. So what are we going to do now? I'm going to say that this 28, sorry, there was 28 marbles that Ali had. But what happened to these 28 marbles? They were given to Roy. They were given to Roy. So the original amount of marbles that Roy had was over here. And the 28 was extra from Ali. Only after Ali gave him 28 marbles, Ali had 3 times as many as he. Okay? So these 28 marbles previously belonged to Ali. Therefore, we can say that this is the original amount of marbles Ali had. So now that we have our model, guess what? We can just say that this is 1 unit, and we can make everything else the same so that it is easier for us to find the number of units. Okay? Now let's read the other sentence. If Ali gives 106 marbles to Roy, they will have the same number of marbles. So let's duplicate the model. This is the original amount of marbles that Ali had. And this 1 unit was the original amount of marbles that Roy had. Now, I'm going to say that if Ali gives 106 marbles to Roy, then they will both have the same amount of marbles. So now you know why I'm drawing the model like that. Okay? Now, if you compare the two models, do you notice that 106 is equal to 28 plus 1 unit plus 28? 106 is equal to 1 unit plus 28 plus 28. So how do I find the amount of money that Roy has? Roy, 1 unit. So how do you find 1 unit? 106 minus 28 minus 28. And we have found Roy. Now let's take a look at Ali. How many marbles does Ali have? This is the amount of marbles Ali has without giving anything to Roy. Okay? So that will be 3 units plus 28 plus 28 plus 28 plus 28. Or, if you want to make it more simple for yourself, look at this model. It's just 1 unit plus 106 plus 106. And that means 50 plus 106 plus 106, which gives us 262. So now we have found how many marbles each of them has. How do we solve this using the ratio method though? Let's write Ali and Roy. They said that Ali has 3 times as many marbles as Roy, but that is only after Ali gave 28 marbles to Roy. So let's go back to our model. Do you notice that this 28 marbles belongs to Ali? Only after he gave it to Roy, then Roy had 1 unit. So, since we know that this 28 marbles belongs to Ali, we're going to give it back to Ali. And we're going to take it back from Roy. So let's read the other sentence. The other sentence says that if Ali gives 106 to Roy, they will have the same amount of marbles, right? So let's say Ali gives 106 to Roy. Now we know that these are going to be the same. So let's write it down. 3 units plus 28 minus 106. Well, we'll get a negative number. 3 units minus 78 equals to 1 unit minus 28 plus 106 plus 28 plus 78. So if I bring this over to the other side, I'll get negative 1 unit. If I bring this over to the other side, we'll get positive 78. 2 units equals to 78 plus 78. So 1 unit must be 78. Okay, how many marbles does Ali have? Ali has 3 units plus 28. And that gives us 78 times 3 plus 28. And what about Roy? This is how much Roy had at the beginning. 50 marbles. And we still end up with the same answer. So students, this is how we solve if questions. You can either use a model or the ratio technique, whichever you feel more comfortable with. Okay? In the exam, never ever force yourself to use a certain strategy. Only do the strategy that you're comfortable with. Because if you're not comfortable with it, there is a really high chance that you might make a careless mistake. This is Coach Leo from Tutify Education, and we help students improve 2 grades within 3 months or ace the math competition. Now, ratio techniques is just one of the 28 powerful strategies and tools I teach here on this channel. So make sure to hit follow and stay tuned for more. But if you want to start applying these ratio strategies to real exam style questions, You can join a free trial class with us online. Just click the link in the description and register today.